I'm going to go over a concept I'm going to call modifying circuits. I don't know what this is really called, but this is a pretty common type of question that can appear on the AP exam. So what happens is they'll give you a circuit. It can be more complex than this, but just for example. So this one, I'm just inserting a battery and a capacitor with values V and C. So the question is basically going to ask you what is going to happen to some component of the circuit if we disconnect it here and then we change this or that. So, for example, they might ask you, what if we let the capacitor charge up, reach equilibrium, and then we disconnect from the rest of the circuit and start screwing around with it, for example, changing the distance between the plates or increasing the area. So there's these questions can take an endless number of different forms, but basically what you have to figure out is what is going to stay the same and what is going to change. So let's work through that example I just talked about. So we're going to disconnect the capacitor from the rest of the circuit, like so. So now whatever charge is on the two plates of this capacitor is now locked there. Because the circuit is disconnected, those charges have nowhere to go. So how much charge is that? Well, we just use the equation Q is equal to C times V. And since C and V are our values for the capacitor and the voltage source, that's exactly the value of the charge on each plate. So that cannot change now. So whatever else they have you change, let's say they double the distance between the two plates of the capacitor. That means capacitance is going to drop by half, but charge cannot change, so voltage must double to make the charge remain the same. So that's the sort of reason you have to think about. What is going to stay the same? Let's look at another example where something else is going to stay the same. Similar situation. We have the voltage source and the capacitor, V and C. But this time we're not going to disconnect the circuit first. We're just going to immediately start changing the distance between the two plates of the capacitor. Well, if we look at Q is equal to CV, rearrange a little bit, we find that V is equal to Q over C. Then, since voltage must stay the same, if we cut capacitance in half by doubling the distance between the two plates, then the charge must decrease by half as well. Another sort of concept you have to grasp with problems like this is that voltage must be equal along continuous lengths of wire. So for example, let's say in a third example, we start with the same circuit, V and C, and we let it charge up. So now we have the original charge Q equals CV. And now we are going to disconnect it as before, but now we are going to reconnect it. We're going to reconnect it to another capacitor over here. I'm just going to move this to make it a bit clearer what I'm referring to. This is value C, and maybe this capacitor is value 2C. So now the question asks you, what will be the amount of charge on each capacitor? Well, there is some amount of charge total, Q, on this entire length of wire. This is all one continuous conductor. And there is exactly Q charge on it. And of course negative Q on the opposing face. So we just have to figure out what is going to be the ratio of charge between the two capacitors. How much of this big Q is going to end up on the C, and how much of it is going to end up on the 2C. To do that, we're just going to set up a simple system of equations. So of course Q1 plus Q2 must be equal to the big Q. And then also, we know their voltages must be the same because they're both connected on either end. So the voltage of each capacitor, well, you can see the equation right there. V is equal to Q over C. So Q1 is equal to, V is equal to Q1 over C, which is going to be equal to Q2 over 2C. 2C. So really, since we don't actually know V right now, don't get tricked, I'm kind of mixing up letters here, but this V is no longer our original V from the circuit. So really, this left side is kind of unhelpful, and that's the equation we actually get. So now this is pretty simple to just do some substitution. We can, for example, do Q minus Q2 over C is equal to Q2 over 2C. And then we just need to solve for Q2. So we might find Q over C is equal to Q2 over 2C plus Q2 over C, which we can then simplify into 3Q2 over C is equal to Q over C. So then we just, or sorry, this is, we get 2. Yeah, 2C down there. So we get rid of that, and we find Q is equal to 3 over 2Q2, or 2/3 of the original charge, is going to end up on that second capacitor, that bigger capacitor. So then final answer, there is 2/3 big Q over here, and there's 1/3 big Q over here. Alright, so hopefully that's enough to kind of give you an example of how to think on these sort of modifying circuits questions. You just have to figure out what's going to stay the same, what's going to change, and then use your circuit equations, use your circuit laws, whatever you want to call them, to figure out whatever it is the question asks you.